200 tons. This is the immense weight some military transport units reach when fully loaded for deployment. Why are these machines engineered to such extreme physical dimensions? It only looks obvious that bigger is better for heavy hauling, but in reality, the sheer scale is a mathematical necessity to distribute the pressure of nuclear warheads and massive power plants across unstable terrain. One can notice how these giants occupy 2 full highway lanes simultaneously during rare transport maneuvers. The equipment gradually moves across landscapes where any standard civilian vehicle would immediately become immobilized. Some of these structures are designed specifically to navigate through deep swamps, shifting desert sands, and active combat zones. But this is just the beginning. Everything only gets more complicated as the focus shifts toward the payloads. Some of these machines are engineered to carry missiles capable of eliminating entire cities from the map with a single deployment. Because regular roads cannot sustain such concentrated pressure, the trucks utilize dozens of reinforced wheels and specialized independent suspension systems. It is visible how the chassis remains level even while the tires climb over obstacles several feet high. These vehicles remain in active service today despite their age and the extreme costs of maintenance. It seems simple to replace them with modern alternatives, but the specialized engineering of these platforms remains unmatched in specific theater operations. The process is only gaining momentum as we transition from general heavy transport to the most specialized mechanical monsters ever designed. 10 of the most outrageous military trucks ever built define the peak of heavy engineering. Some of these machines are so extreme in their proportions and power that their operation on public roads is strictly prohibited by international safety standards. The mechanical complexity of these units involves thousands of interconnected hydraulic lines and massive engines generating thousands of horsepower. One can notice the heavy vibration in the earth as the most powerful unit on this list approaches. It is a machine that redefines the limits of what is physically possible on a mobile platform. Thus ends the introduction to the world of extreme military logistics and heavy transport engineering. 240 horsepower is the output generated by the massive 14.9-liter V8 diesel engine heart of the Kraz 255B. Why would such a relatively low horsepower figure be paired with such a colossal displacement? At first glance, the power seems insufficient for a vehicle of this scale, but in reality, the design focuses entirely on massive torque rather than speed. This high torque allows the truck to tow loads exceeding 40 tons through deep mud, over steep mountain paths, and across the most unforgiving terrain. Manufactured in Ukraine starting in the 1960s, this machine became a definitive symbol of brute mechanical strength and absolute reliability. The 5-speed manual transmission is built to endure brutal usage without failure. One can notice how the reinforced axles and heavy-duty leaf spring suspension, equipped with dual shock absorbers, maintain stability even when the vehicle is at its maximum capacity. The 6x6 drivetrain ensures that power reaches every wheel for constant traction. It is visible how the massive tires and wide fenders dominate the silhouette of the frame. This truck was engineered to operate in environments where almost no other vehicle could survive, relying on purpose-built engineering rather than complex electronics. Everything only gets more complicated as the scale of the missions increases. 9 meters is the total length of this intimidating physical presence. The cabin remains strictly functional, providing seating for 2 and only the most essential instruments. The engine sound is loud and metallic, characterized by a raw diesel rumble that signals its immense capability. It does not end at this stage. Throughout its history, the vehicle was deployed to transport heavy artillery, light tanks, mobile bridges, and vital fuel supplies. During the Soviet-Afghan War, it earned a legendary reputation for navigating narrow mountain trails that were inaccessible to other transport units. Because the mechanics are so simple, the truck can be repaired in the field using only a limited set of tools. The process is only gaining momentum. Thousands of these trucks remain in active service today across rural Ukraine, Kazakhstan, and Central Asia. Civilian sectors such as mining and logging continue to utilize the platform for its durability. Some individual units have reportedly logged hundreds of thousands of kilometers without requiring a single major overhaul. One can notice the sheer endurance of the design in extreme survival scenarios. A well-known account describes a military convoy trapped for several days in a severe blizzard in Kazakhstan. While other machines failed, only the Kraz units managed to break free under their own power. They did so while simultaneously towing other damaged vehicles vehicles through the snow. Transition to the next level. One of the greatest achievements of Czech military engineering represents a completely different approach to the battlefield. The Tatra Force T815-7 is built by the historic Tatra Trucks company. It embodies decades of technical evolution in off-road heavy-duty transportation. The equipment gradually reveals a shift from mechanical simplicity to cutting-edge engineering solutions. 12 7/10 liters is the displacement of the massive Tatra V8 engine that serves as the mechanical heart of this machine. Why is such a high-capacity power plant necessary for a tactical vehicle? The sheer scale of logistical and combat missions requires a reliable source of immense torque. A single ignition cycle initiates the delivery of over 440 horsepower to the drivetrain, but this is just the beginning. 14 gears within the automatic transmission manage this output, meticulously balancing raw pulling power with necessary fuel efficiency during long-range deployments. It is visible how the cooling systems manage the heat generated by the massive engine block during sustained operation. The process is only gaining momentum. At first glance, the chassis might look like a standard heavy-duty assembly, but in reality, it utilizes a unique central spine frame. This engineering choice allows for the integration of independent swinging half axles, a signature technical hallmark of the Tatra design philosophy. This specific mechanical architecture ensures that all wheels maintain constant contact with the terrain surface, regardless of how uneven or broken the ground becomes. One can notice the smooth articulation of the components as the truck traverses obstacles. Drivetrain configurations are modular and highly adaptable, ranging from 6x6 and 8x8 layouts to the massive 10x10 variants. Every single version is equipped with a fully independent suspension system. This allows the heavy platform to maintain stability and precise control while navigating steep slopes, deep snow, thick mud, or shifting sand. It gets more complex further on. Electronic traction systems monitor the movement of each axle, adjusting torque distribution in real time to prevent wheel slip. The camera glides along the undercarriage where the swinging axles move independently of one another. This provides unmatched off-road performance in the most demanding environments. The exterior of the vehicle is defined by a clean, functional, and no-nonsense aesthetic. The forward-placed cab is designed for maximum utility and can be upgraded with heavy armor plating to protect the crew. Furthermore, the cabin can be fully fitted with chemical, biological, radiological, and nuclear protection systems to ensure survival in contaminated zones. The chassis remains level even when the wheels are at different heights, demonstrating the technical superiority of the swinging axle design. From here, the vehicle is prepared to transport its payload across any geographical barrier without hesitation. This concludes the primary overview of the power and structural systems of the tactical truck. 40 degrees is the incline angle the Tatra Force conquered during rigorous field testing while carrying a maximum payload. Why would a heavy truck need to perform such extreme maneuvers without any external assistance? It would seem that standard transport routes do not require such steep climbs. But in reality, tactical operations often take place in unpredictable terrain, where the ability to move independently determines the success of a mission, a feat that deeply impressed even the observers from NATO. The chassis maintains its stability as the wheels grip the uneven surface. Several countries, including Israel, India, and the United Arab Emirates, have evaluated or officially adopted various versions of this machine. They appreciate the modular design and the rugged, reinforced build that allows for extensive customization. It is visible how the vehicle serves as a versatile foundation for complex equipment. But this is just the beginning. Some specialized variants have been transformed into mobile missile launch platforms and high-tech command centers. The equipment gradually integrates with the heavy-duty frame to ensure operational readiness in remote zones. Everything only gets more complicated as the focus shifts to different engineering philosophies. One can notice the transition from the rugged hills of the testing grounds to the industrial precision of Germany. Here, a machine operates that blends brute strength with surgical accuracy. The MAN SX45 is designed and manufactured by the German engineering sector to meet the most demanding specifications. It does not end at this stage, as the structural integrity of the vehicle is refined for specialized hauling. The camera glides along the massive axles and the reinforced cab structure. This transition marks the move toward a machine where every component is calculated for high load durability. The manufacturing process of the German heavy truck follows a strict sequence of assembly and testing phases. One of the key stages of heavy vehicle engineering is thus demonstrated through these diverse platforms. 680 horsepower is the maximum output generated by the MAN D2868 diesel engine at the core of this machine. Why is such immense power concentrated in a 12.4-liter V8 configuration? The vehicle must maintain momentum while carrying massive logistical loads across terrain that would stop standard transport. This high-mobility military truck, known as the SX45, was engineered by the German company MAN specifically to fulfill heavy-duty missions under the most demanding NATO standards. It only looks obvious that a truck of this size would be cumbersome, but in reality, the engineering ensures agility. A 12-speed automatic transmission manages the power flow, distributing torque through an 8x8 all-wheel drive system equipped with specialized differential locks. One can notice how the independent suspension, fitted with reinforced shock absorbers, compensates for deep ruts and uneven soil. This mechanical setup ensures stable handling, even when the chassis is loaded to its maximum capacity with cargo. The process of traversing obstacles is only gaining momentum as the digital systems monitor traction in real time. The cab is positioned high and forward, featuring a clean and functional design characteristic of German industrial logic. It is visible how the modular structure allows for the installation of heavy armor plating to protect the crew during battlefield operations. Inside the cabin, space is allocated for 5 soldiers alongside an integrated suite of digital controls, communication arrays, and optional navigation hardware designed for complex theater environments. It gets more complex further on. German efficiency is audible in the steady hum of the engine as the vehicle transitions between logistical roles. The SX45 functions as a versatile platform, hauling everything from fuel bladders and ammunition crates to large-scale artillery pieces and modular command units. Its design ensures total compatibility with the logistics chains of various allied forces, which simplifies the movement of supplies during multinational operations. At first glance, the truck is a ground-based asset, but its utility extends to aerial deployment. 100% of the vehicle's design considers the constraints of rapid strategic transport. The SX45 fits within the cargo hold of a C-17 Globemaster aircraft, allowing for deployment without the need for time-consuming disassembly of major components. It is visible how the low profile and calculated dimensions facilitate quick loading and unloading in remote zones. Everything only gets more complicated when the environment shifts from the airfield to the field. During recent NATO joint exercises, the equipment gradually proved its reliability across a spectrum of difficult surfaces. The truck moved with precision over deep snow-covered trails, through thick muddy slopes, and across loose gravel roads without losing traction or mechanical timing. The all-wheel drive system and high ground clearance allow the tires to grip the earth firmly, even in the most unstable conditions. Transition to the next level of technical capability reveals another significant detail. 445 horsepower is the output of the Detroit diesel 8V92 TA 12-liter engine driving this military legend. Why do global armed forces prioritize standardized components in vehicles like the SX45? Logistics costs can cripple a long-term campaign, so utilizing universal parts ensures that maintenance demands remain relatively low even during intense operations. This focus on reliability has made the platform a preferred choice for organizations seeking high performance without an overwhelming mechanical burden. But this is just the beginning. Next in the progression of desert-capable machinery is the Oshkosh HEMTT, an 8x8 workhorse defined by its multiple personalities. Originally engineered for complex military logistics, it has established itself as one of the most versatile machines ever produced for the United States military. It is visible how the vehicle transitions between roles depending on the specific nature of the mission. It can serve as a primary hauler, a mobile refueling station, a heavy-duty tow truck, or even a self-contained mobile repair shop. 1,700 Newton-meters of torque allow the vehicle to maintain consistency while under a heavy load. It only looks obvious that a truck this size would be slow, but in reality, it reaches a top speed of 62 miles per hour on flat stretches. Despite its heavy-duty construction, the machine carries a payload of up to 11 tons through the most punishing environments. The process is only gaining momentum as the vehicle moves from paved surfaces to unpredictable terrain. One can notice how the 8x8 drivetrain and reinforced independent suspension interact to conquer the landscape. These mechanical systems allow the truck to power through deep sand, navigate sharp inclines, and cross dry riverbeds. Such obstacles are common in harsh desert theaters like the Sahara or the Sinai Peninsula. The equipment gradually absorbs the shocks of the uneven ground, protecting both the cargo and the structural integrity of the chassis. Driver fatigue is significantly reduced by the inclusion of an automatic transmission. This system makes operations smoother under extreme climatic conditions, allowing the operator to focus on navigation rather than gear synchronization. At first glance, the military aesthetic is its most defining trait, characterized by a flat front and a wide modular body. The rugged design is unmistakable as the camera glides along the reinforced exterior panels. Everything only gets more complicated when examining the interior engineering. The modular body allows for rapid reconfiguration between transport and support roles. One can notice the precision with which the hydraulic systems and towing apparatus are integrated into the frame. This ensures that the vehicle remains a functional asset, regardless of the logistical challenges presented by the desert environment. The machine continues its steady movement across the dunes, demonstrating the engineering balance required for modern military logistics. 1,000 horsepower and a wide modular body define the initial visual impression of this rugged machine. Why have so many of these heavy tactical vehicles been converted into specialized expedition rigs by the most demanding overlanders? It only looks obvious that a military truck serves a single purpose, but in reality, its versatile chassis provides the perfect foundation for global travel. These custom-built motorhomes based on the heavy platform have successfully crossed the Namib Desert, navigated the vast Australian outback, and traversed the rugged terrain of Patagonia. Equipped with high-capacity solar panels, auxiliary fuel tanks, and fully integrated living quarters, the trucks transform into completely self-sufficient mobile bases. One can notice how the oversized tires and high ground clearance allow these units to remain isolated for several days or even multiple weeks without the need for external supplies. But this is just the beginning of their utility. Beyond the world of private exploration, these heavy-duty platforms have been utilized on major cinematic film sets to transport sensitive equipment into the most remote desert locations. The equipment gradually moves across shifting dunes and rocky plateaus where standard logistics vehicles would fail. Always reliable and always tough, the machine maintains its structural integrity under extreme thermal and mechanical stress. The process is only gaining momentum as the engineering moves from 4- or 6-wheel drive to even more complex configurations. Transition to the next level of heavy hauling requires even more contact points with the ground. 100 tons of pulling capacity is the standard for the Oshkosh M1070A1 heavy equipment transporter. When the United States Army required a vehicle capable of moving 60-ton main battle tanks across unpaved terrain, this specific model was developed. It is visible how the 10-driven wheels distribute the massive weight of the tractor and its cargo to prevent sinking into soft soil. Getting stuck becomes nearly impossible due to the mechanical synchronization of all 5 axles. It seems simple at first glance to add more wheels, but in reality, the steering geometry and torque distribution must be calculated with extreme precision to ensure the truck can turn. The metal frame remains rigid while the suspension absorbs the irregularities of the battlefield or the desert. The heavy equipment transporter continues its deployment, moving the largest assets in the military inventory to their final destinations. This phase of heavy logistics ensures that the most massive loads reach the front lines or the workshop without delay. 700 horsepower is the mechanical output generated by the massive engine of the primary heavy equipment transporter utilized by the United States Army. Why did the military require such a specialized machine for logistics? It seems simple to transport a vehicle on a standard flatbed, but the M1 Abrams tank weighs nearly 70 tons and requires a platform that combines extreme durability with tactical mobility. The Oshkosh 1070 Alpha 1 was engineered specifically to solve the problem of moving these armored behemoths across unstable terrain and through active combat zones. The heart of this machine is an 18-liter Caterpillar Sierra 18 diesel engine. One can notice how the deep and steady vibration of the power plant remains smooth even as it idles under the weight of the massive steel chassis. This engine is paired with a 7-speed automatic transmission specifically calibrated to manage enormous torque loads without sacrificing mechanical performance. The process of moving the vehicle is only gaining momentum. 8x8 is the drivetrain configuration that ensures power reaches every wheel through an intelligent torque distribution system. The camera glides along the reinforced suspension where heavy-duty springs and hydraulic shocks absorb the impact of uneven ground. This allows the truck to traverse deep mud or rocky soil without losing its structural integrity. It only looks obvious that a truck of this size would be slow, but in reality, it can maintain a speed of 72 kilometers per hour, which is approximately 45 miles per hour. 10 meters of total length makes the 1070 Alpha 1 a dominant presence on any tactical road. The equipment gradually reveals its rugged design through a tall cab and massive tires that provide the necessary ground clearance. Everything only gets more complicated as the truck moves into hazardous environments. Optional armor is integrated into the cab to protect the crew, while the engine sound remains deep and steady. Because the mission often involves long-range hauling under pressure, the interior is built for a crew of 6 personnel. One can notice how the filtration systems operate to keep the air clean in contaminated or dusty environments. Air conditioning provides the necessary climate control for the soldiers inside, while additional shielding offers protection against light munitions. The truck functions as a mobile command and transport hub for the heaviest assets in the fleet. The Oshkosh 1070 Alpha 1 completes its technical deployment, moving the weight of the Army toward its destination. 130 tons of total weight were hauled by a single M1070A1 during a high-stakes military exercise within the Arizona desert. Why did this specific operation involve moving 2 M1 Abrams tanks in a single convoy? While it seems a standard heavy transport could manage the load, the extreme thermal conditions of the desert would typically cause critical engine failure. The mission was executed without a single instance of overheating or mechanical breakdown, proving a level of technical endurance that very few transport vehicles on the planet can match. One can notice how the truck maneuvers through urban zones and across unstable desert terrain to deliver armored vehicles and missile systems. It played a vital role during operations in Iraq and Afghanistan by transporting tanks over long distances. This logistics strategy ensured that the heavy armor reached the front lines without placing unnecessary wear on their tracks. But this is just the beginning. The vehicle is equipped with specialized systems designed for operation in contaminated environments and features reinforced shielding against light blasts. Reliability during long-distance hauls has directly led to a drastic reduction in mission downtime for ground forces. It is visible how the heavy-duty suspension absorbs the impact of uneven ground, while the cooling systems maintain stable internal temperatures. The process is only gaining momentum. At first glance, the task of moving such massive cargo across roadless regions seems simple, but in reality, it requires a chassis capable of surviving where infrastructure is non-existent. It gets more complex further on. The Soviet Union introduced the MAZ-537 in the late 1950s as a specialized solution for towing heavy tanks and oversized military equipment. It was engineered specifically for regions with little to no infrastructure, where standard logistics vehicles would inevitably fail. It is visible how the massive wheels and high ground clearance allow it to navigate through terrain that would immobilize even industrial farm tractors. Everything only gets more complicated. The machine remains one of the most legendary heavy military tractors ever built due to its ability to function in extreme geological conditions. Its core design allows for the transport of missile systems through mud and deep snow. The engineering focus was entirely on raw pulling power and mechanical simplicity. This transition from modern Western logistics to Soviet-era heavy tractors marks a shift in the evolution of military transport. The material remains a testament to the durability required for global armored operations. The next stage of the technical analysis begins with the internal components of these heavy-duty tractors. 38 liters is the total displacement of the massive 12-cylinder diesel engine situated at the heart of this machine. Why is such an immense volume necessary for a vehicle that produces only 525 horsepower? A standard engine might stall under the resistance of soft earth or steep inclines, but the sheer torque output of this power plant allows the vehicle to tow loads exceeding 50 tons with relative ease. The engine emits a raw metallic roar that intensifies significantly as the internal load increases. At first glance, the mechanical layout seems focused purely on brute force. Power is channeled through a multi-speed manual transmission that is paired directly with a full 8x8 drivetrain. One can notice how the reinforced torsion bar suspension absorbs the unevenness of the terrain, providing the durability required for operation in extreme environments. This allows the machine to function reliably in regions with little to no infrastructure where standard logistics would collapse. It gets more complex further on. The vehicle measures approximately 9 meters in length and features a compact armored cab designed with seating for 2 occupants. It only looks obvious that this is a transport vehicle, but in reality, the squared-off body and heavy frame project a level of mechanical aggression typically reserved for tanks. tanks. The wide tires and low profile emphasize its functional purpose over any aesthetic elegance. The equipment gradually proved its worth by transporting heavy assets like the 72 and 55 tanks, as well as rocket launchers and heavy artillery. Its performance in harsh climates made it indispensable across deserts, frozen steppes, and mountainous terrain. But this is just the beginning of its operational history. During the Soviet-Afghan War, the vehicle became known for hauling damaged armor across destroyed roads where other transport units failed. Everything only gets more complicated when traversing such unpredictable landscapes. One can notice the slow, deliberate movement of the 8 wheels as they grip the loose soil of the mountains. Decades after its initial deployment, some units remain in active service within civilian roles throughout Russia and Central Asia. The transition to the next level of its utility occurred as it moved from military convoys to industrial hauling. The massive frame and reliable torque continue to serve in one well-documented capacity after another. The mechanical journey of the machine continues through the most difficult landscapes without haste. One well-documented incident involved a single MAN SX45 being utilized to pull a derailed locomotive back onto its tracks in a remote region of Siberia. Why was such a massive, heavy vehicle required for a task usually reserved for specialized railway cranes? The answer lies in the total isolation of the site, where the frozen ground and lack of infrastructure made any other equipment useless. The truck successfully moved the multi-ton steel locomotive through sheer friction and torque. It is visible how the 8 wheels bite into the permafrost as the tow cables reach their maximum tension. But this is just the beginning. The vehicle took on various civilian roles throughout Russia and Central Asia. It only looks obvious to use such machines for logistics, but in reality, they were the only means of transporting heavy industrial components to inaccessible construction sites. One can notice the slow, methodical movement of the chassis as it traverses terrain that would swallow standard transport. While the MAN SX45 delivered raw pulling power, its successor added versatility and became a more adaptable platform for evolving industrial needs. The transition to the next level of transport design was not merely about increasing engine output. It seems simple to just add more horsepower, but in reality, the entire cooling and transmission systems required a complete technical overhaul to handle prolonged loads. The equipment gradually transitioned from a specialized heavy tractor into a multi-purpose heavy-duty carrier. Everything only gets more complicated when the weight of the cargo exceeds 100 tons. One can notice how the hydraulic systems of the newer models react with millisecond precision to changes in the center of gravity. The process is only gaining momentum as these machines move deeper into the unexplored territories of the continent. The material and heavy equipment arrive at their destination through the relentless work of these heavy tractors. This phase of the transport operation concludes with the successful delivery of the cargo to the remote site. Thus, the heavy transport reaches the end of its difficult route, fulfilling its role in the industrial chain.